I'm Justin Turner. I'm with Microsoft out of Las Colinas. I'm in CSS, so support. I do Premier support. I work with lots of large customers that have large contracts, expensive contracts that pay to speak with us and support. This topic is Active Directory performance troubleshooting. And it's kind of a scary deal if you don't really understand it. These calls that we get on are typically large 50-person bridge calls. I'm routinely brought into these large calls and people are yelling at each other. And you got CEOs calling other CEOs to engage us. Like, we need this fixed now because this is major business down situation. We have Exchange servers aren't sending, no mail flow. We have people that can't log onto the domain. Essentially, their business is stopped. This is a very scary deal, and especially the people on the calls, you can tell, you can usually hear it in their voice. This is probably the worst day of their life at work. They're afraid that if this isn't fixed right away, they're going to lose their job. And I've been on quite a few of these over the years, and I've actually seen people lose their jobs on these calls. Just someone ran a script, someone did the wrong thing, resulted in an Active Directory performance thing, and we'll get into what I mean by Active Directory performance. What we'll go over here are the symptoms, cause, and resolution. And so these first couple slides are just setting the groundwork for Active Directory performance, so we have a good common understanding of what I mean by that, because that can mean a lot of things to everyone. And so this is just going to be like a high-level overview of symptoms, cause, and resolution. Then we're going to actually look at the troubleshooting workflow, and what we call in Microsoft is peeling the onion, because this is a multi-layered problem usually. You start off with some data collection on one server that reveals something else, and you kind of follow the trail, and you're peeling off multiple layers as you go along. Then we're actually going to look at what the common scenarios are that we see. And finally, preventative measures and references. So this would be a good part to pay attention to so that you don't have to do the troubleshooting stuff. So you can avoid these really scary deals. So symptoms, cause, and resolution of Active Directory performance problems. And this is, like I said, it's just a high-level overview before we go deeper. So what are the symptoms? Let me ask real quick, what do you think an Active Directory constitutes an Active Directory performance issue? So logons, yes. What else? CPU on the server. CPU. That's what I'm focused on here. What specifically with CPU? LSASS, the local security authority. I mean, essentially all the work a DC does is in this process. So that's a pretty good indicator of an Active Directory performance issue. And that's what I'm after in this session. And there's a lot more that it could be than just high LSASS CPU. I mean, generically, we could have an Active Directory performance problem and not see any CPU utilization. The DC may be, in order to respond to the client request, he may be waiting on another third party. You know, this may be some additional work, like we're trying to do secure LDAP binds, and it's slow. And that's a client thing. You know, the client-side application needs to do a secure LDAP bind, so it provides a user certificate. DC has a server auth certificate. And the DC, before it allows that connection, may have to do some CRL checking to make sure the client is who he is. His CRL, his certificate hasn't been checked. So there may be other scenarios where CPU isn't high. And I also say here, it could be high memory as well. Have you guys seen LSASS high memory issues and what that means? Like you see on screen, I got 94% CPU utilization for the LSASS process. Memory is at 1.59 gig. Is that high? Could be. 58% of the memory is in use on this server. So generically, a domain controller is optimized for reads from the database. And what we'll try to do is cache as much of the contents of the database into memory so that more searches come along. We can satisfy those search requests through our cache in memory versus having to go to disk, which is a much slower operation. So this number, this memory, just because it's high, and it's a large amount, doesn't necessarily indicate a problem. Typically what you'll see is an Active Directory database. Let's say it's 2 gigabytes. You may see LSASS grow to 2 gigabytes just because we'll attempt to cache that, as much of that. And that's kind of our guidance, right? Is you guys have heard probably that you must have at least as much memory as the size of the database plus some more in order to satisfy that criteria. But it could be an issue if, let's say the database is 2 gigabytes and that number is 35 gigabytes right there. So what would happen in that circumstance? If we only have a few gigabytes of memory, we have a 1 gig database, a 2 gig database, but we have 35 gigabytes of memory for LSASS. What does that mean? Well, it means we are having to swap pages from the disk into memory quite frequently, and that slows us down quite a bit. And so I won't focus on memory on this talk, but I do want to let you know that in 2012 R2, we made a trade-off in how we do things. So we'll tend to not go run hot on LSASS CPU. We'll tend to favor using more memory. And so I've seen now where customers may have a 1 gigabyte database, tons of CPUs. Maybe we have a 32 proc box and 8 gigs of RAM or something. And you see this number just grow and grow and grow, and we start seeing this paging scenario. Paging in and out of disk, things are slow, things are not working. It is an AD performance problem at that point. And one of the reasons for that, and we'll dig into really the common reason for all these issues is we start allocating more and more memory as these requests come in. And if we have some long-running requests that we can't satisfy fast enough, we'll just keep allocating memory in 4 megabyte chunks. And so it looks like a memory leak, essentially.
You guys already fixed that over a period of time?
So the question is, we've already fixed that.
Every version you guys have a memory leak problem.
Yeah. So like I said, this was a change in 2012 R2, where the guidance typically was, hey, have as much memory a little bit larger than your database size, your Active Directory database size, so that you can cache that. But now in this 2012 R2 change we did, that's not good guidance anymore. But the question was, did we already fix that? And yeah, there is an update to kind of revert that behavior. That should be out next month. So you'll see that, be on the lookout for that. And after the conference, if you want more info or anything, just feel free to email me, justin.turner@microsoft.com. And I'll say, hey, yeah, it's released, here's the KB number or whatever, or any other thing. Okay, so that's the DC side symptom. But then we have the client side problems. And this is really why it's an issue, right? We don't typically just look at our DCs and go, oh, CPU's running hot, there's a problem. There's only really a problem if there's some sort of application failure or slowdown, things aren't working. And this is when you guys get the call. Say, email's not working. It looks like it's AD. So what sort of client-side symptoms do we see? Well, it's entirely dependent on the client-side application, of course. But routinely we see timeouts. The application will fail due to the slow response from a DC or no response from a DC. Like I mentioned earlier, slow secure LDAP binds. And this is kind of a perennial one, a very common one, is repeated prompt for credentials. So maybe it's Outlook. User gets prompted for credentials, they enter their credentials, credential box, they're entering the right credentials, and the credential box keeps popping up. It's like, hey, this is my password, this is my username and password, I know I didn't change it. And you just see this repeated prompt for credentials. And so what makes these issues challenging is sometimes it comes in here. Help desk is alerted to, the application not working, email's not working. It's sometimes hard to correlate that to a problem with AD. And that's your goal, and that's hopefully what I'll be able to reveal here, and methods to do that, how to identify that. But ultimately, your goal here is to track this down, this client-side problem, to an AD problem as quickly as possible. Because I've seen cases that worked at Microsoft that have 200 hours of labor into them. That means the engineer working it has actively logged 200 hours of labor into this case. And dealing with the Exchange Outlook and the Exchange team. And then this is, going on for a couple months. They're troubleshooting, they're collecting data, collecting dumps, which is typically the hardest set of data to look at and what adds time to these cases. And then eventually they discover, it's like NSPI calls or LDAP calls to the DC aren't being responded to quick enough. And then they call us, and then we go, let's look, and you'll see my troubleshooting workflow. Let's just do this. Okay, it's this. And it's not typically a hard problem once you find that it's a domain controller performance issue. So probably the key takeaway from this is once you do have those client-side application failures, try to correlate that to an Active Directory problem if possible. And like I said, it's entirely dependent on the client-side application. Hopefully there's good logging in the application, but you may have to use things like network captures and process monitor. I mean, that's my fallback. If I don't know what file the app logs to, I use process monitor to see, or I use process monitor and a network trace to kind of get a look to see what's going on under the covers. The other thing I'll mention about this is Exchange is really good about pointing out that there's a problem with Active Directory. Do we have any Exchange people in the room? A good many of you. So maybe your goal for attending this is because Exchange is always complaining that something's wrong with AD. So hopefully we can get you fixed up here, and you won't even have to call us with the problem. You can just troubleshoot it yourself. So what is the cause? And like I said, we're just still in a high-level overview here. But generically, the cause of an Active Directory performance problem are excessive or inefficient workloads. And that's essentially what does the DC do? What work is he doing? He's typically doing LDAP searches, responding to searches from clients. Could be NSPI queries from Exchange servers as well. But still all search type related behavior. Security Accounts Manager, or SAM. Local Security Authority work. Kind of a more recent one that we've seen lately with large customers that have large Exchange deployments is change notification, LDAP change notification. And this is not as common. I've actually only seen a few cases on it, but it bears repeating, or bears mentioning here, that as an application, you can register to be notified when an object is updated in Active Directory. And if you do this, anytime that object is updated, the DC needs to go and tell the client. And this is different from AD replication change notification, if that's what you're thinking of. But this manifests itself in the performance log we'll see in a second, and DS notify queue size is the performance counter. And why I'm mentioning this is if you have like a large, so Exchange makes heavy use of change notification, LDAP change notification. I think there's, what are there, like 15 services now for Exchange? Each one of them does change notification. And that's when I said I've seen it with large Exchange deployments. That's a few hundred to 1,500 Exchange servers can really hammer DCs with this change notification workload. And we're going to look at what those workloads are and how to see what the DC is working on in a minute. And then, so that's excessive or inefficient workloads. The other thing we have is bottleneck conditions. And this is not OS, you typically have your disk, CPU, RAM, network type bottlenecks. We're not talking about any of that here. I mean, you can find great resources on that. We're dealing specifically with Active Directory type related bottlenecks, and that would be maybe max concurrent API, null domain auth or null domain lookups. Have you guys heard of that null domain auths or null domain lookups? A few. So, I mean, null domain auth would be maybe in my client-side application, or it's a front-end website that goes and does some work. I have a user account. I need to enter my username and password. And instead of entering domain /username or user@contoso.com, my UPN, I just say my name's Justin, username Justin, and password. And so so that's called a null domain auth scenario, and you also hear it called an ambiguous name. So it's a username without a domain name. And the problem with that is, if there's no account named Justin on the local Active Directory database, we'll go and traverse our trust. So if we have lots of trusts, we'll go and search our partners who we have trust with and look for this account named Justin. And each of those trusts that we traverse to find this user account to help satisfy this request, we may wait up to 45 seconds. So if you have a large number of trusts and you have this name, and one time is okay, right? But usually we see it happening quite frequently, thousands of these sometimes. You have a really chatty application that's just providing username and not a password, or not a domain name. So that's an null domain auth. There's a setting that will disable that behavior, but the default in Windows Server 2012 Active Directory domain controllers is to do this behavior. I get an ambiguous name, I don't have the account name local in my database, I'll go traverse each trust and look for it. Null domain lookups, same sort of concept, but instead of like doing auth, we're just doing an LSA lookup for an account name without a domain name. Of all these workloads, I would say the most common is the LDAP search thing, because usually DCs are just responding to searches. That's what we typically see. And of actually troubleshooting and resolving these, the null domain auth and null domain lookups are probably one of the more challenging scenarios because we don't have great logging enabled by default for them. So the logging we'll look at today is really to cover these top scenarios. The bottom two scenarios you would see manifest itself in a netlogon.log and for the null domain auth scenario. And then for null domain lookups, that would be in something called an LSP logging, or it's LSA logging. And that's some logging you need to enable. All right, so we looked at symptoms, we looked at cause, and now we'll look at resolution. And there's multiple ways to resolve these problems. And I've kind of break them down here in client side versus DC side fixes. And I'll present them in order that I would prefer that you go after resolving it. So on the client side, what can you do? Once you identify there's a client causing an Active Directory performance problem, and that's usually the case, it's something client side that's overloading the DC or doing an expensive search or just doing some behavior that's killing us, what we can do is modify the app if you have your application developer there. But, I mean, sometimes that's not easy, right? We don't have source code access to modify that. But if it's a script, you can typically modify the script. Improve the search. If it's an LDAP search, you can optimize the search typically. We're not getting into the DC side of this in a second. For like SID lookups, so the SAM and LSA, the LSA workload, we do name to SID and SID to name work. We're like trying to resolve a name to a SID or a SID to a name. What we see there when this problem hits is there's just a ton of this type of work coming in, and it's repeated for the exact same accounts over and over again. So the client always does these lookups. And so what we would prefer to do in that is modify that script or app so that it has a cache it maintains, a local client-side cache, so it doesn't have to do these repeated prompts. And then finally, on the client side, apply your updates and rollups. We find, in Windows Client, we find things, updates that are applicable that help resolve these kinds of scenarios all the time. And we'll see in the mitigation section what sort of updates and rollups. But what I would say here is, and then the applications, if they have rollups, like Exchange, for example, releases it seems like a rollup is every 3 months now. Get those in, because as we work these cases, and we find like, oh, this query that Exchange does is very expensive. It makes the DC do a lot of work. We'll tell them, file a bug, and they're pretty good about fixing it and putting it in the next rollup. So keep on top of your updates. So reducing that work that DC has to do from the client side is preferred here. On the DC side, what can we do? Well, let's say it's a search that's really expensive. So we're searching for either the filters complex. You guys familiar with LDAP search? You've done those? Look at a search filter. We'll look at them in a second. But so we can modify the filter so it's optimized. And in the references section, I have a link to an article on how to do exactly that. But the other thing we can do is if our clients are searching on non-indexed attributes, and there's a need to do this, like the drink attribute. Have you guys seen the drink attribute in Active Directory? There's an attribute for like favorite drink, I think is what it's for. They didn't index that by default. I don't know why. So let's say the application does search for, they want to return this attribute data. And so now, anytime the DC receives this request, he has to go and essentially, he doesn't have an index, so he has to search every row in the database for this attribute, these attribute data. So if we see this sort of behavior, we can choose to resolve it on the DC side by indexing these attributes. The ramifications of doing that, I mean, none of this is free on the DC side. None of this is free. It all comes with a cost. Indexing an attribute, it's a fairly easy thing to do. It requires a schema update. Then we need to actually populate the index on each DC. But this incurs some database growth, and then, of course, replication. Now we're replicating that. It could be like we're searching GCs, and it's not included in the partial attribute set, so we might choose to add it to be replicated to global catalog servers. And so that's indexing. Modify configuration is another option we can do. So we can change the DC side default behavior so that things like, you saw me, the null domain auth and null domain lookup, you can disable that behavior. And that's just a registry key change on the DC. But once again, if you do that on the DC side, there may be ramifications of doing that. You may have an app that depends on that feature, that being able to traverse those trusts to work. So if you disable this, it's kind of a global setting. Once you disable this, and this is called the never ping setting for null domain auth, or LSAR restricted isolated name level for the LDAP ambiguous name lookup, LSA lookup. If you disable that, you may break the app. So once again, it's preferred to do the client-side fixes. So what's another client-side thing we can do? Well, we can redistribute the load and do that via changing your site configuration, ensuring your clients map to sites and they map to, they go to other DCs. That's a little bit harder to do. And then finally, increase capacity on the DC side. Add more DCs, more VMs or whatever, add more CPU, more RAM. If this is your solution, I would actually not call it a solution to the problem. I mean, if you're going to just do this, increase capacity, then we don't even need to attend the session, right? This is about troubleshooting, and if you're just going to increase capacity anytime you get this problem, then there's no need to troubleshoot. Of course, the cost here is, it is a viable solution to the problem, but it's not a cost-effective solution. We can't just throw money at the problem. Any questions so far?
Maybe I should ask later. But page file recommendation for the GCs, because nowadays hardware is a lot cheaper. So most of the GCs domain controllers we're getting is like 24 gig of RAM and 48 gig of RAM. So the conventional page file size recommendation has been 1.5 times of the RAM. Where now we are not following that. Do you have any specific recommendation for those larger size of memory?
No, so the question was about page file sizes on domain controllers. The guidance being typically we have at least 1.5 size time RAM. And I would just say use what you can afford, especially considering disk space is so inexpensive now. I'll have this in the references section. There's a lot I can't cover in this section, a lot on capacity planning. And there's a really great document one of my colleagues wrote, Ken Brumfield, on capacity planning for domain controllers. And I have a link to that in the references section. But you can also just search on AD capacity planning and find the link to it. It's linked to from a blog on our UX writers, our writers that write the content on TechNet. But it's also in a TechNet wiki, because it was pulled down from the site, but someone copied and pasted it to the TechNet wiki before it was pulled. It's a really great resource for answering those kinds of questions and for understanding how to size your DCs appropriately. Because that's the common question we get is, I need, I have 40,000 users. How many DCs do I need for the users in that site? And the answer is it depends. I can't answer that question because it depends on your environment. You have applications that do different things. We can't just say, 40,000 users equals 2 DCs. We got to look at a lot of other things. You have to do this baseline, do some performance baseline monitoring, and see what sort of, where your peak loads are, and determine your SLAs. Like how long is it okay for the client to wait for a response? What do I want my DCs to run at? Here we're talking about high CPU utilization for domain controller, but really that's highly subjective. What is high? If I have a DC at 50% CPU utilization, is that high? You can't answer that question. Maybe if you saw the screenshot where it said like 94% or something, I would say, yeah, that's definitely high. But maybe 50% is high or 60%. Maybe that's high because when you planned your deployment of Active Directory, you planned for 20% or 40% CPU load. And in all your monitoring, you see, yeah, even at peak, we are at 40% CPU for LSASS. And now it's at 60%? What's going on here? I need to understand why we have a divergence and what's typical for my environment. So that's why I say that the CPU utilization, even that argument is somewhat subjective and highly debatable, but just realize it's helpful to know what your DC's typical load is at peak and at rest and averaged over time. That way you'll know what high is. I mean, I have a customer that they want their DCs at 40% CPU utilization all the time. Because if it's not at 40% CPU utilization, they're wasting hardware resources. That could be, maybe they're spending too much money. And it's pretty funny. They almost have it down to like CPU tick counts and resource allocation. And they do this monitoring to such a great extent that they understand when there is an issue in their environment. And they're doing the monitoring and the testing. If they see a DC sitting at 20%, maybe they have too many DCs in that site. But the goal here, at least for them, is they need enough DCs to handle 40% CPU load, even if they were to lose one of the DCs. So I have, let's say, 3 DCs in a site. My goal is to have them at 40% CPU. I don't want the loss of one DC to cause an outage in the site. Because what we'll see in a lot of these cases is you haven't planned your site deployment quite correctly, and maybe you just have 2 DCs in the site. They're both running at 50% CPU utilization. One DC goes down for some reason. That other DC has to pick up that load. And now it's at 100%, and it's not responding to clients, and it goes down. And then, okay, what happens next? Well, we have this domino effect. Now clients move to other sites, DCs and other sites. The next closest site probably, hopefully, right? DC locator. What happens there? They didn't plan there right. That DC incurs a load, it goes down. And I've seen this happen. And I've seen this for AD performance cases, and I've seen it with AD replication as well. Some problem encountered on the one DC took down their entire environment because of this trickle effect, this domino effect that happened.
Exactly the same as the exchange planning facility where you establish a BCP site, thinking that two exchange servers is going to be good enough for them to fail over, but two exchange servers just not good enough to handle everybody. So it's pointless having BCP site with less capacity so in servers. So you got to have if you're going to have a BCP site, for example, you're going to have adequate hardware to handle all the load.
Yeah, good. So yeah, have the hardware to handle the load. Any questions on these solutions here? You'll see, once again, we're still in the high level.
I mean, with a typical scenario like this, where you have a scale up or scale out.
Scale up or scale out? Mm-hmm.
In a scenario where if you deploy a lot of say exchange servers in the same site, for example, the old exchange is going down to one DC anyway, regardless of how many DCs you have in the site. So, do you recommend scale out DC deployment for those application farms or scenario, as opposed to scale up in the DCs?
Yeah, I think, so the question is around scaling up a DC, meaning adding more hardware, like CPUs and RAM to a DC, versus scaling out. What more, meaning adding more DCs?
So, if you have, say, $100,000 in budget, for example, would you recommend having, say, 5 DCs?
Yeah, I don't really get into the game of DCs, amount of DCs versus like just adding more DCs. I look at it from the standpoint of what are my SLAs, and do I have enough CPU? I look at it from CPU core perspective.
Right.
So if I have a few DCs, I'm actually just going to look at the actual how many CPUs are in that box, and I'll just maybe add a few more, like if it's a VM scenario. And sure, I have enough resources to meet my SLAs.
Exchange servers typically are asking for 8-to-1 core ratio.
Right.
So, but then again, if you have 5 DCs and 1 DC is not satisfying at the 8-to-1 core ratio of the exchange server, it's pointless having that DC. You know what I mean? So I'm talking about with 5 VM based two high-spec DCs.
Yeah, like I said, I don't really care about that. Like, I don't really get into how many DCs versus CPU cores. It's going to be entirely different and dependent on your deployment. You're talking about Exchange, and so I would go with the Exchange guidance because they're the application, and Exchange team and the Exchange blog, I think it's You Had Me at EHLL, has very good monitoring of AD, and their guidance is what I would stick to for how to capacity plan for Exchange. All I care, like I said, all I care about is the resources on the DC. If the boxes are overutilized, then I'm adding more cores, or I'm adding more VMs, more DCs. But like I said, it's highly subjective on the application. Yep. Yeah, so the question is around applications that are hard-coded to a single DC. And that DC becomes overburdened and falls over. And instead of the application falling over to other DCs, it fails over. It fails as well. And I would say that's a problem with the application configuration. I mean, Exchange should be using DC locator. That's why I can't speak to the Exchange configuration aspects of that. I've seen people hard code to specific DCs, but the application, whatever it may be, should be smart enough to use ds-get DC calls and use DC locator. So if the resource I'm using goes down, I can move to another domain controller.
It does do that, but it seems to be that for the 15-minute or the trailers token, it'll kind of do the locate and pick one, and then keep using that for a set period of time before it redoes the locate.
Oh, okay, I see. So you're saying that Exchange does do that. It will switch to another domain controller, but there's a time period in which it'll stick to the one DC. And so that sounds to me like DC locator as a cache. And we won't go out and rediscover another DC until cache expires. So once again, I'm not an Exchange person, but how I would handle that is you may modify how quickly the client switches over to another domain controller in that scenario. And so there's a registry key we added in Windows Vista and Windows Server 2008 era. It's called force rediscovery interval. That will tell you to go out and rediscover a new DC.
It is appropriate to ask an Exchange person, but it's kind of complicated by the fact that the DC is still up. It's just slow.
All right.
So it doesn't necessarily not pick it.
Oh, I see. So yeah, your comment is the DC is still up, so it's not actually going to go and look out for someone else.
So typically what happens is that you reboot the DC, and it becomes okay for a period of time, and the problems build up again.
Yeah, so I mean, if I have that sort of scenario, you'll see the steps I use. Typically in Exchange, and I used to work with Exchange engineers, they had their solution was called a GC reboot. They had an Exchange problem, they would just reboot the GC. Fixed, done, move on, right? Not really. So we're going to look at here the data, and we want to not have to reboot DCs. I mean, if that was my solution, I could just have a scheduled task that called shutdown restart, right? There's my fix. Fixserver.vbs, it just calls shutdown restart. So not a good solution. So now we get into the troubleshooting workflow, and that's what we call peeling the onion. And high level, what this involves is the DC side data collection. So at this point, you know you have an Active Directory performance problem, high SL CPU or whatever the case may be. You want to jump to the DC the client is using. And what that usually entails is hopefully there's logs that tell you which DC the client is using. Or maybe you just go and make educated guesses like, well, the clients are in this site, so it's likely using these DCs in this site. Or you can use logging like net logon logging that tell you that, or a network trace that would tell you which DC we're using. NL test ds get DC is usually a pretty good indicator. Some people use set with a set space L to see the logon server variable, which is just an indication of the server we used at logon. So that's not really a good method, but it's an okay method. But in any case, we know the DC that has the performance problem. The first thing we need to do is grab something called an AD, Diagnostics Data Collector Set. Have you guys heard of this before? An Active Directory Diagnostics Data Collector Set. See a couple head nods. Have you heard of SPA or Server Performance Advisor? No. So this is really just inside of Performance Monitor, and we're going to look at that in detail in a second. We're going to grab this, and we're probably going to grab the 1644 enable and grab the 1644 events. We'll see what that is. And then there's also the client-side data collection. So you found the DC that had CPUs running hot. You grab this AD diagnostic data collector set and the 1644 event log and probably a network trace or something. In there, in that data analysis, you can look and see, oh, this is the workload, and these are the clients issuing this work to this DC. And so once you have that info, then you jump to the client side and get whatever relevant piece of data you need to determine what the client's doing, which process or application is responsible. So this is what it looks like in a little more detail. For this DC side data collection, our first goal is to map the workload to the client-side caller. And what I mean by that is determine what work the domain controller is doing, what work is causing the performance problem. Find out, once we classify that, find out which clients are doing this, issuing this work. And we do that via the AD Diagnostics Data Collector Set, the perfmon thing I mentioned. 1644 events, we'll see in a minute. Network trace, task list, SVC, netstat minus ANOB. That sort of initial DC side data collection is what you do to get to the client side. So that piece of data, this data here at the top, the DC side data, all that does is it tells us the workload in the client. But now our goal is to find out what on that client is causing that problem. Sometimes you can make educated guesses based on this data and go, oh, it's always searching for these exchange-related attributes. So it's likely the clients are these exchange servers and the application is likely exchange. So sometimes you can infer what the client-side process is that's responsible for that work. But in many cases, you can't. And so we need to do the client-side data collection. And our goal with the client-side data collection is to see what script, process, or service is running on the client that's issuing that workload. And the way you do that is, it's highly dependent on what you did in your DC side data analysis. Maybe it's LDAP workload. And so now all your goal is to find the process on the client that's issuing that request. And our goal there ultimately is to identify, to figure out who's doing it so that we can change that behavior. So have you guys seen task list or netstat before? Yeah, a few of you. Most, it looks like. Network trace, once again, process monitor. And this client-side data collection is heavily dependent on what you find on the DC side. In a lot of these cases, we collect DC side data for this issue, and it doesn't really identify anything, so we have to go back and add more logging. And once we find it, then we know clients. And so it's not such a linear approach as this. Sometimes it's, grab a little bit more logging. Okay, now I understand. But ultimately, you're still following this workflow, and you're always working your way to find that client-side process. And the goal with that is to do one of our resolution steps that I mentioned. Ideally, we reduce that work that the client is doing. That's the preferred solution. I say if it hurts, stop doing it. If it's causing pain on the domain controller, stop doing that. That at least buys you time. Maybe it's just shutting down those machines. Maybe you can't find the client-side process, but it's like this group of machines and their workstations, and you're like, I don't know what's causing it. I have this laid out fairly simply on the slide, but this is actually the hardest part of the whole problem is coordinating this data collection. The right data collection at the right time. Because if you collect the data when the issue is not occurring, it's not useful. And a lot of these cases involves getting the DC side data, the client side data from while the issue is occurring. So once that DC side data collection, that identified the client, I may go to the client and the process or application or script is not doing that work anymore. And so now I gotta wait. I gotta wait and collect the data. But at least I know the machine or machines that are causing the problem, and I can be set up for the next time to collect the data. So here's the DC side data collection. Once again, the Active Directory diagnostic data collector set, the 1644 event log, and this is what we're going to look at in detail in this section. We look at primarily those two things. So let's look at the AD diagnostic data collector set. This is just as simple as, I'll close that. This is just a 2012 R2 DC. It's the same. We added Active Directory diagnostic data collector set with Windows Server 2008. It's the first time we have this built in. But really all you're doing is opening up Performance Monitor on the domain controller. And this is where you go, data collector sets. In here, you have system-defined data collector sets, and you have user-defined data collector sets that you can create. This is the data collector set that I want to run. All I do to run it is just go in here, click that, and click this little green play button. And now it's collecting data. And it shows us right here where it's logging the data to. So what is it collecting? Well, it's collecting a couple of files with the ETL extension. This is a binary log file that's not of much use to you unless you have a parser or a method to decode this file. So what that means is if you just want to look at the Active Directory.etl file, you couldn't do that today unless you worked at Microsoft. Hopefully that story changes because you can do this in Network Monitor and Message Analyzer. And we're working on getting that decoder available to you in the next release of Message Analyzer. I'm hoping for the January release, but I can't make any promises. But the goal here is to be able to decode that and you not have to have a support case in order to look at that piece of the data. But what this is doing is it's running this data collection for a period of 300 seconds or 5 minutes. It's collecting those files. And it's doing the ETL trace data, and this is like all the work that's coming into the DC, the searches and the internal calls, the SAM lookups, the LSA lookups. All the stuff the DC's doing is being logged, including who the client was and the searches and the filters and all of that useful data that you wouldn't be able to get from a network trace because in the network trace that's typically encrypted. So there's a lot of useful stuff in the Active Directory ETL. Alongside that, we're also collecting a performance monitor log, a perf counter log, that has all the counters that we look at, or I would say most of the counters that we like to look at for AD issues. And what it's going to do after 300 seconds is stop collecting the data and then generates an HTML report. And you can look at the HTML report, and that's why I'm showing you this. And it's taking data from the ETL and the performance counter log and correlating it into a useful report in most cases for you to be able to look at and hopefully be able to do that work of mapping the workload to a client-side caller. You know it's running by clicking that, and you see it's running. When it's done, it's going to create a report under the reports directory. And by the way, like I said, you can also see where it's logging the data to. So if you didn't have this up in the UI, you could go there and grab that folder with all those files and copy it to another machine, or zip it up, and also look at it outside of perfmon. But in the reports directory, like here's the one it's working on. It's still collecting data. And I can stop this manually or wait the 300 seconds. So I'm just going to stop that. And after I stop it, it says compiling, so it's creating that report. But I can look at a prior report that I ran. And this is what it looks like. You get the machine name at the top here, the time and date stamp of when it ran, how long it ran for, any warnings or alerts that it found. CPU load, just like a performance overview. And then we have all these expandable selections. Something called Active Directory, CPU, network, disk, memory, hardware configuration, report statistics. What I do when I look at these is I make sure that I'm looking at a good set of data, first of all. And usually I'm looking at them because there's an AD performance problem, and they said LSASS was running hot. And I go, okay, well, let me look at the report. And so the first thing I'm doing is going into the CPU section in process, in image statistics. It shows me the top 3 CPU utilizers here. And I do see, in this one at least, we hit 50.3%. And so maybe that's, like I said, that's whether or not that's high CPU, that's subjective, but that tells me that, yeah, this may be a good set of data to look at, to dig in further. And then I can exceed right here the exclusive activity statistics. These are the frames that it found in the ETL and the types of activity that it was working on. And we can see the generic nature of the work it was performing here. And what I see is LDAP request took up 45% of the CPU, so he's the highest caller. So now I kind of have a good understanding of what was going on the DC, what work it was doing. So then,
If you expand the absence, what do you see there?
oh, nothing useful. Question was, if I expand LSASS, what do I see? Usually there's not anything else that I see in there. So that's the CPU section. That's where I went. Of course, if it was a disk or memory problem that I thought, I might look into break those sections out as well. But for this scenario, it's LSASS CPU. So now I'm going to go into this Active Directory, and this is where I spend most of my time in this report, is in this Active Directory section. And what that looks like is this. And it's broken down, and you'll see a slide here of what all these things mean. So I'm looking at Active Directory. It has search at the top. DCs do a lot of search, work on a lot of search requests. Directory services is the core Active Directory stuff to the database adds, modifies. Of course, replication. We need to replicate off our changes, so those are replication statistics. LDAP, Security Account Manager, LSA, and if I break open one of these, let's look at search. You can see the kind of thing you'll see in here. It shows me unique searches. And I see, and this is, in a lot of these cases, where I find the culprits is right here in this report. I see a client-side caller IP address with the port. I see the type of search, the scope of the search. It was a deep search, meaning it wasn't like a base or subtree search. See what LDAP filter was used, what index was used, and the amount of time we spent on the search. So these are fairly low, but I think there's a lot of them. So in the world of AD performance, sometimes you get in here and you see this guy's hitting request per second is 1,000 and response time is 6,000 milliseconds. And you go, that's probably our guy. He's the culprit. Or sometimes you see it like this, where there's a lot of the same sort of activity and there's not any one thing that stands out. And so generically for Active Directory performance, you can either have like the first thing is like the big gorilla beating up on the DC, Exchange is hammering on the DC or the application, and it's one box just overloading the resources, crushing it. Or you have death by 1,000 cuts, which is hundreds or thousands of clients making a lot of little work for the DC. When all aggregated together, they overload the DC. So this report is good for just seeing who the caller is. Notice we get the IP address and the port it's using, which is where netstat and task lists come into play, where that helps. We see directory search by object, types of searches, searches with the most CPU, clients with the most CPU usage, indexes used. So that's the search area. Here's a directory service area. Directory add by clients. And so when you look through each of these sections, you can get an idea of what it was working on at that time. And it's only useful, like I said, if you collect this data from the period of the problem while the issue's happening. Otherwise, I mean, so I get some people that say, here's the AD diagnostic data collector set, and the DC's not doing anything. So it's a waste of time to look at. Replication activity, LDAP here. And then, so what I'm typically doing for like an LDAP search problem is I see that it's search most likely, but I can confirm that in this performance counter section. In the performance counter section, I see some counters that begin with this ATQ. So that stands for asynchronous thread queue. Have you guys heard of this counter? No? So what this is primarily it's used for LDAP search. And you see ATQ threads LDAP right there. Well, this is a kind of a finite resource. So typically when you look at performance problems, you look at bottlenecks on the server. Hardware, disk, RAM, whatever. From an AD perspective, I find one of our smallest, our easiest bottlenecks is this ATQ thread pool. And how that's used is, where I see ATQ threads LDAP up there, what that means is, it says maximum 8. That means I have a maximum, or let's look at ATQ threads total actually. So I got ATQ threads total equals 8. And the default for a domain controller is to have 4 per CPU core. I have 4 threads per CPU core. And what these threads are used for, the ATQ threads LDAP is, if I have a search comes in, it has to use a thread. So for as long as that search work is running, it's using up one of these threads. And let's say I have 4 really gnarly searches come in that the DC is having to churn through, or 8 in this case, since I have 8, so this is a 2-core box. So I have 8 searches that come in, and the DC has to spend a great amount of time working on it. Until that search work is done, that thread is not released. And meanwhile, other searches are coming in, and then you start seeing the queued request counters go up and the queue delay counters. So this is where I could go and right away determine if I actually have a search problem. But I'll get into that in a minute. The other thing I'll mention real briefly is you can create your own reports, user-defined. You can say new data collector set. give it a name, create from a template, Active Directory Diagnostics. And this allows you to modify it. So I might go in here and add more performance counters to look at. I might change the stop conditions, so I can right-click Properties, go to Stop Condition, and change it from overall duration of 5 minutes to maybe maximum size of 200 megabytes, and restart the data collector set at limits. And maybe this is 500, might be better. So what this would do is, as long as I'm running this, it's going to collect data until the data set is 500 megabytes, and then it's going to start a new data collector set. And this is useful for when you can't know when the problem is going to reproduce, but you want the data to be collecting the whole time. And that way you don't miss your window of the issue occurring. So you'd have to do that anytime you need to modify what Active Directory Diagnostics provides. And finally, I'll also mention our default data collector size is not good. Well, changing it in the next version. But you go in the data manager on this, and you need to change this policy where resource policy from delete largest to delete oldest. Because what we'll have go on is you start collecting data, and maybe your 5 minutes of data generates a 2 gigabyte ETL file, and that's very common to see on a busy DC. And the default data manager resource policy is once we grow beyond a gig, we'll just delete the largest file. And that may be the file that we just, for the data collector set we just took. And then so how that causes us a problem is then we can't create an HTML report for you to see. So if you have that scenario, you need to go in here and change this. Change it to delete oldest, and you might change this to a larger value. And the other thing I'll mention too is with the resetting at limits, sometimes 5 minutes of data is too large. I end up with I've seen a 10 or 11 gigabyte ETL file. There's the process that creates that compiles and creates that report. It runs at a low priority, so it takes a long time to create that report. I've seen it run hours, and it actually times out after 6 hours. So you don't want a 4 gigabyte ETL file. If you can't run your data collector set for 5 minutes, if that file is too large in a 5 minute period, you need to reduce the time you're collecting the data so you have a smaller data set so that the report gets created. All right, any questions on the Active Directory Diagnostics? What sort of performance hit is there on collecting the data? That's a great question. So you've seen me this whole time go in the interface and click Start. That's usually not the kind of thing you want to do on an overloaded DC, right? You don't want to launch new interfaces. What you would typically see on like a really busy DC, like that DC running at 97%, it may just sit there and time out or hang trying to open that. So there is a slight performance hit for that. And I'm glad you mentioned that because you can also... You could do it remotely, yes. You can remotely connect to Perfmon and launch it that way. You can also launch it from a command line. And that would be the command line to start that data collector set. You use the logman start and then the name of the data collector set. That's the built-in one system / Active Directory Diagnostics. And to stop it, you just say logman stop and then the file name. If you had created a custom one or user-defined one like I did, I called it 80perf, it would be logman start user whack 80perf. I know. So you're saying you've seen a server so busy that the performance monitor data was missing samples? Yeah.
Any way you can change that behavior? Is it decline of medicine?
I don't know if I've seen that. I've seen where you can modify how frequently we collect a sample. So in here, actually it's in here. Their sample interval, change it from 3 seconds to something else. You can change this. I mean, you would modify this if you had this going over a longer window, right? The issue's not reoccurring. There's not a 5-minute period, but you want to monitor throughout the day. You'd probably change the sample interval to something larger so that your file, your BLG file, isn't too large to look at. But I don't know that I've seen. If you email me after, I can look up to see if we have some articles on that. Sounds like a bug, is that what you said? Yeah. All right. Oh, and we are. So with DC workload, I already kind of talked about directory operations. Need to speed it up because we're running low on time. But AD replication, this is essentially what you saw the report. Those were the fields in this report. And what I'm showing here is what directory services means. It means DS modify. These are directory operations to the local database. Replication, what does that mean? Is it FRS or AD replication or DFSR? It's AD replication. LDAP, what is LDAP? Searches and binds typically. This is just the generic nature of this work. We have Kerberos Key Distribution Center, so that's just Kerberos ticket operations. Security account manager, what kind of info goes in there? That's DS crack names, calls to DS crack names API, which is just trying to enumerate a user or group, and other account operations. And that's the workload of the security accounts manager. In LSA, we have SID to name and name to SID lookups. If you've ever used PS get SID from sysinternals, that's what it's leveraging. And then NTLM is NTLM operations.
Do you also consider like some of the feasible role holders may perform, resource may have to be allocated for some of the feasible role?
So the question is around resource allocation dependent on FSMO roles. So the only thing, we have a good article on that. And primarily if there's going to be a FSMO role that's going to be overly utilized, it's the PDC emulator. And the reason why for that is because for some reason application developers tend to think the PDC emulator is the most up-to-date DC in the environment. And even internally, we'll write stuff that requires the PDC, other applications that'll look to the PDC. So that's the DC, that's the FSMO role owner that I tend to see get overloaded. But the search term for that article is piling on effect and PDC, and you'll see a lot of recommendations for that. But if there was one FSMO role owning server, it'd be the PDC I would give more resources to. So moving on, 1644 event logging I mentioned a couple times. What this is, and this is a busy slide, I include this mainly for reference. But all you do on a DC is just set the field engineering, the diagnostics field engineering key to a value of 5. And what that causes is any LDAP searches that come into the DC that exceed a certain threshold, it'll log one event ID 1644 to the directory service event log per search. So now I know who's asking for, who's doing the search request. That's our defaults. You don't have to add these other keys. We have internal defaults for each of them. Our default is if we searched more than 10,000, we'll log an event. If we searched, and that's expensive searches, and inefficient search results, essentially if we have 10% visited versus return rate, I visited 10,000 objects and I only returned 1, then I'm log an event. And then we added in 2012 R2 the search time threshold, which allows us to specify a time-based threshold. And this is backported to 280.094.5, so to 2008. So you can you can define any searches that exceed a certain time threshold, log an event. And the default is 30 seconds or 30,000 milliseconds, which is too large in my opinion. If I had a search that was taking up 30 seconds, that's tying up one ATQ thread for 30 seconds. Then it just takes 7 more searches to come along to just knock this DC over. This is the event that gets logged, and this is the data that's in it. And it's useful in that it calls out the client IP port. You see like starting node and filter, what type of search it was, a subtree search, how many entries were visited versus how many were returned. This shows us 319,750 entries were visited in the Active Directory database, but it only returned 46 entries. That's fairly inefficient. Ideally, we are only searching a very limited amount and returning the same amount. We see what index was used. In this case, the DNT index was used, which is essentially every row in the database was looked at for this search. And then we get the search time, how long it took. This search took essentially 6 seconds. Exchange complains when searches exceed 50 milliseconds from a DC. They log an event saying, hey, this DC took more than 50 milliseconds to respond to me. 6 seconds is really bad. And then finally, the attributes preventing optimization was also added in 2012 R2. And that tells us what attribute was searched on in that search filter that prevented the LDAP query optimizer from making that search complete in a timely fashion. And then finally, you get a user account. Here's the service account or user account that was used to issue the search. However, data analysis is difficult when you're just looking at one event, right? We're looking for patterns when we do this. We're doing pattern matching, and we want to identify what, unless you get lucky and find a 30-second search in an event, it's going to take a long time to search through a DC's event logs. Fortunately, we created, a colleague of mine created a script and published it to the TechNet script gallery to take this EVTX, this directory service event log, grab those 1644 events, import them to Excel, and create pivot tables so that you can help analysis of this problem. And so this is what it looks like when you run. And there's a bunch of tables. And all this did is it extracted those 1644 events and created these sheets with different pivot tables. And so very useful here. This top IP page shows me this client issuing 10,892 searches, the average time of the search, what percentage of total. And if I were to expand on that, you could drill through this stuff and see what those searches were and like the timestamps and things. And this other page, top time IP, once again, you got an IP grouping, and it shows us, instead of pivoting on the count of searches, it pivots on the total search time. And this shows me this one client is issuing the majority of the searches and causing the largest work for the DC. So now, when you have one of these problems, it's just a simple matter of enable field engineering registry value. You set it to 5. There's no reboots or anything required. You collect data. Maybe you modify the thresholds to reduce them to get those 1644 events. And then export that event log to Excel or to EVTX format and run this script. When you run this script, you're going to want to be on Windows 10 or later. And ideally, you have a 64-bit version of Excel, because as it turns out, it takes a lot of memory to create these tables from a PowerShell script. And you tend to run out of memory on like 32-bit clients for Excel. And then if you have a really large event log, you might want to break it down into chunks of 1644 events. Oh, I'm over time. Real quickly, common issues. LDAP searches versus ATQ threads. Once again, there's that ATQ threads LDAP. Our max ATQ threads is 128 here. it equals the total of 128. That tells me that I've hit that max. And then since this is ATQ Threads LDAP, it's LDAP search activity. You can also see that requests are being queued. These are requests that are having to wait in a queue for a thread to become available. And how long these queued requests take to be serviced on average in the max time. Number one common issue, if you take nothing else away, know that in this report you can find if this is your problem by looking at those two values, seeing if ATQ Threads LDAP or ATQ Threads Other equal ATQ Threads Total. And in my references section of the slide is a blog that goes through all of this. And it's on the Ask DS blog. So you can just go to Ask DS, and that's where my team blogs to. And it does a great job of explaining how to interpret this data and what each of those things mean. And the other common issue is SAM calls, and that's just SAM enumeration. And that reveals itself in the report here in the image statistics. You see its CPU. You see what it's working on. It's DS dir search and SAM enum users in domain. You see the requests per second. And you go to the SAM section, clients with the most CPU usage, and you see client equals SAM. Instead of before you saw an IP address, now we see it's an internal caller. It's a security accounts manager. Request per second equals that. So those calls are taking up 79% of the CPU. This is where it'd be helpful to be able to interpret that AD ETL file, and that would show you who the actual client was, because it's SAM doing the work on behalf of a client-side caller. So the thing you can do today is just get a network trace and hope that you see these essentially group or account enumeration searches going on. And then the null domain auth and null domain lookup scenario I talked about, which is the never ping. And we're out of time, so I can't get through this demo. I apologize for that. So I'll move on to the preventative measures. So we'll look at DC and client-side updates, DC sizing and capacity, general configuration optimization guidance. So here are the updates that I would recommend to install on DC role computers. There's an update to add that additional level of detail to those event 1644s that was backported to Windows Server 2008, 2008 R2, and 2012. It's included by default in Server 2012 R2 and later. There's an LDAP query optimizer update that was released and backported. This improves the efficiency in which the LDAP is able to optimize the query. So it selects more optimal indexes. It has to read less into memory each time. And it essentially improves the search, the workload, how much work the DC has to do to satisfy the results of the search. And so this was released as a backport, and some of those backports had backport meaning we first came out with it in 2012 R2, and we released updates to allow 2008 R2 and 2012 to leverage it as well. Some of those backports, though, had some regressions, in which case some of the searches weren't optimized. So we've had a number of updates to this backport, and the latest and greatest is released in a security update. So if you're installing your security updates on your DCs, you have the latest query optimizer. That MS15096 is where we released that. The other update, I talked about the whole LSASS memory issue. It's due in December. It'll be a separate out-of-band release. It won't be a security update. So if you actually want that, send me an email, justin.turner@microsoft.com. Recommendations for clients, just generically install relevant updates and roll-ups. There's something called the slow boot, slow logon rollup for Windows 7 and Windows Server 2012. That is essentially the service pack that, it's not really a service pack, but it's like a service pack for those clients. Get those updates, install them, exchange, make sure you're on the latest roll-ups. DC sizing, this is one of the last slides. DC sizing and capacity, use a 64-bit OS. We have much more user mode memory, more non-page pull memory addressable. We go from 128 megs to like 16 gigabytes or something. It's just not very smart. I mean, if you call me and I got 80 performance problems and I'm looking at a 32-bit DC, I'm probably going to go, well, does it do the same thing on the 64-bit servers? Sure you have sufficient memory to cache the DIT, the Active Directory database, and ensure the DIT and log files, deploy them to a separate disk than the system drive with sufficient spindles to support the I/O generated by that. And once again, I'm going to make a reference to that capacity planning document for that level of detail you're going to want. There's a lot more than I can cover in this session. Sure you have sufficient cores to handle load, and you only know that if you're doing that capacity, that performance monitoring. The proximity load. Have your DCs in the same site with your applications. That's preferable. Sufficient boxes to handle availability and redundancy. Once again, more capacity planning stuff. And so generically, what I would do, if you don't have, even if you don't have an AD performance problem, do this when you get back. Enable that 1644 event log registry key. It's on your DCs. Set field engineering to 5. Increase the size, I would say increase the size of the DS event log because it's going to start logging 1 event per search. Once you got some data there, run that script. The script is, that's a very simple thing to do, and that shows you fairly quickly things that you probably didn't know were going on. I showed this to a customer. He didn't even call it about AD performance. I was like, let's just do this kind of a value add kind of thing I do. Hey, let's just see. I want you to try out this new script we have in this method to look at LDAP searches. And he runs it, and we see this one box just hammering DCs with 30-second searches, and somewhere 120 seconds, which is like the default maximum time you can do a search is 120 seconds. So they were tying up searches, and it took 20 minutes, and right away he got value because he saw problem boxes on his client. So you don't need an AD performance problem to be looking at this data. This is something you can do today to proactively go out there and find those bad actors. Find and consider disabling null domain lookup behavior. That's the never ping registry value and the LSAR restricted isolated name levels value. But that's something you need to test. And I have stuff on this in the references section. And be on the lookout on our Ask DS blog. We'll have a lot of these recommendations and updates and document the troubleshooting process in a future blog post. Have a well-defined AD topology. Increase your max current API settings. There's the additional resources I mentioned. All are very good reads and contain a lot more detail than I could cover in this session. So in summary, get that AD diagnostic data collector set. That's your first recourse if you have one of these problems. I just went in there, started the report, collected data. While I'm there, I may not even wait for that. I may enable the field engineering to 5 right away and get those two pieces side by side because that's just exporting an event log and running a script. That's easy work. Just do that. And I have a customer that just runs with a 1644 event logging across several hundred DCs routinely, and they just look at this data. They're using SCOM for monitoring, but they just leave that enabled. Map DC to work. So once you got this data, map the workload, what the DC is doing to the client-side caller. Get the client-side data to identify that culprit. And then finally, to reduce, optimize, redistribute, or increase capacity. So reduce the work the client's doing, optimize the search from the DC side, whatever the case may be. Redistribute or spread the pain, is another way to put it. And this is listed in priority order, or increase capacity. Throw servers at it, throw server cores at it. That's if you have big wallets. I'd like to thank my contributors to this, my members of my AD Perf core team. These are a great group of fellows that helped define and create those scripts and write that content and write all the articles for it. And finally, I love seeing your feedback. So please complete your survey. Tell me what you liked, what you didn't like. And I guess you may get a prize too. So. And that's it. Thank you.